Alright, so I hope this is recording. It's been recording what I write, but it hasn't always been recording what I say. And I've tried to go back and figure out ways to lay an audio track on top of it. And some of them I have, and then others it isn't letting me. And I think I've got it all figured out, and I think it's all working. And I just have to tell you that I'm promising to do my best. So here they're wanting me to subtract these two fractions. They want me to write this as a single fraction. Well, whenever you add or subtract fractions, you need a common denominator. And what I would do here for this one is a little bit different than the one that I did last time, because I can see that I need to factor this denominator. I need to use the x method, and I need to factor this. And I'll tell you what I think is going to happen. I think x plus 6 is going to be one of the factors. So let's come over here and see if I'm right. Let's put down our x. Let's put 11x at the bottom of our x. The first term times the last term, 30x squared. Two numbers that multiply together to give me 30. Well, 5 times 6. And add together to give me 11. 5 plus 6 is 11. So it's just as I expected. I've got x plus 5, and I've got x plus 6, and I already have an x plus 6 there. So that actually makes this problem easier once you recognize it, because these almost have the same denominator. What I need to do is take this first fraction, 3 over x plus 6, and I need to multiply this fraction by the number 1, but I need to write 1 in such a way that both of these fractions will have the same denominator. See, it's missing, this first denominator is missing an x plus 5. So if I put x plus 5 here, well, then I have to put an x plus 5 in the numerator. And now, this problem is so much easier because I have two fractions with the same denominator. And that denominator, now I can write these two fractions as a single fraction, and I'm not going to do anything to that denominator. X plus 5 times x plus 6. Now, I'm going to do the subtraction. I have to combine these two numerators. So this x plus 5 gets multiplied by 3. That means both of the terms get multiplied by 3. Well, when you take x and multiply it by 3, we just write it as 3 times x. When you take 5 and multiply it by 3, hey, that's 15. And 15 minus 2, that's 13, and we're done. So if you recognize that one denominator is just missing a factor of the other denominator, and you multiply by 1, boy, it makes these problems so much faster and easier. I'm not even going to bother multiplying these two denominators together. I'm just going to leave it as x plus 5 times x plus 6. So there's my answer for number 23. Now I'm going to finish out all of these problems since this is recording right now, or at least it looks like it is. I'm going to keep going because sometimes it freezes up and sometimes I lose the videos. So this last time, the directions were simplified. This was not an equation. I can't solve this because it's just combining two fractions. This time, I'm actually solving an equation. I'm going to tell you what x will equal. And since it's a fraction equal to a fraction, they call this kind of equation a proportion, and this is when you cross multiply. And you guys seem to really like that cross multiplying. You did very well at it. So 3 times x is 3x, and 5 times this binomial. I do need to remember to put parentheses because everybody gets multiplied by 5, not just the first term. So now I have an equation, 3x is equal to 5x plus 10. Because remember, they both got multiplied by 5. I need to get the x's on one side of the equation and keep the number on the other side. I need to subtract 5x from each side of this equation. So 3x's take away 5x's is going to leave me a negative number of x's. And 5x minus 5x, they just cancel. So now I have this term 10 on the right hand side. But look, I'm just about done now because I can divide both sides by a negative 2 because the inverse operation of multiplication is division. I want to undo that multiplication. I need to get x by itself, so I needed to cancel that negative 2. And a positive 10 divided by a negative 2 is negative 5. And since I don't have any variables in my denominator, that's my answer. Now I can check that answer. I don't even need a calculator to check the left-hand side. Let's check and see if this is the solution to this equation. On the left-hand side, x divided by 5, well, now I'm claiming that x is negative 5. On the left-hand side, I have negative 5 divided by positive 5. And the question is, when I do this fraction on the right-hand side, it says x plus 2. Well, I'm going to have a negative 5 plus 2. And that's being divided by 3. Are these fractions equal to each other? On the left-hand side, negative 5 divided by positive 5 is negative 1. And on the right-hand side, the numerator, negative 5 plus 2, is a negative 3 divided by a positive 3. That's also equal to negative 1. Hey, that checks. So I know that x equals negative 5 is a good solution. All right. Hey, this problem is done like the last problem. It's an equation that I'm going to try to solve, and it's a fraction equal to a fraction, so they call that a proportion. And one technique to solve proportions is to cross multiply. So if I multiply along this diagonal, and then I multiply along this diagonal, I can set those equal to each other. So along the purple diagonal, I'm going to take the binomial x minus 3 and multiply it times the binomial x plus 5. And here on the right-hand side, 4 times 5 is 20. So I need to make a table or some organized way to multiply these binomials together. And a table is just a nice organized way to do it. I've got x and a negative 3. I have an x term and a 5 term. So now inside my table, I just multiply the outside entries. So you've done this before. Alright. So now along this diagonal, I have what they call common like terms. 5x's take away 3x's leaves me with 2x's. So I have x squared. 5x minus 3x we said was 2x plus minus 15. Now that equals 20. This is a quadratic equation, and we have different ways to solve a quadratic equation. One is to use the quadratic formula, and the other is to use our x method. But in both of those cases, I have to have it equal to 0. And this time it's equal to 20. I can't solve this when I set it equal to 20. What I can do is get a 0 by, if I subtract 20 from the right-hand side, to balance the equation, I have to subtract 20 from the left-hand side. So on the left-hand side, I get a new expression. X squared plus 2x, they don't change. But negative 15 minus 20 is a negative 35. And 20 minus 20, they cancel. And I get that 0 that I was talking about. I need to have this in the form ax squared plus bx plus c. So ax squared, I forgot the x squared, didn't I? Forgot the x. A x squared plus b times x plus c equals 0. So if you're going to solve the quadratic formula, you want to identify a, b, and c. A is equal to 1, b is equal to 2, and c is equal to negative 35. But I claim that it's faster and easier to do your x method. To take the 2x that's in the bottom, 1 times the negative 35, or 1x squared times negative 35 is negative 35x squared. Two numbers would multiply together to give me this negative value, but add together to give me a positive 2. Well, a 7x times a negative 5x should do the trick. Positive 7 times a negative 5 is a negative 35, and when I add these together, 7 plus a negative 5, I get 2. And since the leading coefficient is 1, I can just use the 7 and negative 5 in my answer directly, x plus 7 and x minus 5. So if you have two numbers that multiply together to give you 0, we have a theorem that says, hey, at least one of those numbers has to be 0. Either x plus 5 is representing 0, or x minus 5. This is a one-step equation. Just subtract 7 from both sides, and 0 minus 7, negative 7, plus a positive 7 give you a 0. If you add 5 to each side, when you add 5 here, the negative 5 and positive 5 cancel, and 0 plus 5 is 5. If you look at that, 5 minus 5 is 0, and 0 times anything is 0. So these are the two solutions that I get. There's two answers that solves this proportion. All right. Now, these are some of the ones that we've been looking at recently. We've got 4 raised to the negative 2x power and 16. These type of equations, we can write them with the same base. See, this exponent negative 2x has a base of 4. And I would love to rewrite 16 with a base of 4. So 4 raised to what power gives me 16? Well, I can play around on a calculator if I need to. 4 to the 0 power, well, that gives me 1. I need a 16. 4 raised to the first power, well, that's just going to give me 4. What about 4 raised to the second power? Hey, there's the 16. That's what I wanted. So this equation says that these two numbers are equal to each other. And I can see the bases are equal to each other. So the exponents have to be equal to each other. This negative 2 times some number x, I'm trying to figure out what that number is. When you multiply these numbers together, you get a positive 2. Well, to undo this multiplication, I'm going to divide both sides of this equation by negative 2. Negative 2 divided by negative 2 is just 1. And a positive 2 divided by a negative 2 is negative 1. And there's my answer. And I can check it pretty easily. My gosh, look at this. This says 4 raised to negative 2. And instead of x, I've got a negative 1. And is it negative 2 times the negative 1 equal to 4 squared? And the question was, would you get 16? Well, sure you do. 4 squared is 16. This guy checks. That is a good solution. That is a good answer. All right, 27. Now, I can see on the left-hand side that I have these two bases. They're both 6, so that's nice. They're the same. I can also play around with and get a number 6 raised to what power is 36? Well, again, 6 to the 0 power is not going to do it because by definition, the calculator knows that's the number 1. What about 6 raised to the first power? Well, the calculator also knows that's 6. And 6 raised to the second power means 6 times 6. Hey, 6 times 6 is 36. So I found it. I have a base here of 6, a base here of 6, and a base there of 6. But the problem is on the left-hand side, I need to have just a single base. I've got 2 of them. Well, we have properties that deal with exponents. If you have the same base, suppose we had the number 2, and that was being raised to the third power. And then I have the number 2 that's being raised to the second power. Is there a fast and easy way to determine what the new exponent would be? Well, the slow way to do it would be to write 2 to the third power as 2 times 2 times 2, and 2 squared as 2 times 2, and then to count how many 2's I have. 1, 2, 3, 4, 5. Well, the faster way of doing it is to recognize, hey, I can just add 3 plus 2 and get 5. That's a faster way than writing them all out. So if I have the same base, and I'm multiplying these bases, all I have to do is add the exponents together. I couldn't say the word exponent. All right, so I've got this base 6, and I'm going to add these exponents together because it's multiplication. So I've got negative 3x plus positive 2x is equal to 6 squared. Well, if I have negative 3x's and I add positive 2x's, well, that's just going to be a negative 1x. And if the numbers are the same and the bases are the same, then the exponents must be the same. And I have negative x, or negative 1x if you want me to write the 1, is equaling 2. Well, I can divide both sides by negative 1. And negative divided by negative is positive. They cancel. And a positive 2 divided by negative 1 is negative 2. And there's my answer. All right. Hey, that's the end of it, and I hope that helps. And I will talk to you later. Bye.